So z1 a naught exponential I omega t, this is a complex number. It will have both a real part and an imaginary part. Okay, now if you remember, e to the power I theta is equal to cos theta plus I sin theta. So real part is cos theta and the imaginary part is I sin theta. Okay, so if I write the real part of z, real part of z1, then it will be a naught cos of omega naught into t. Okay, so we can get this expression. Okay, so in this derivation I am going to use this notation of complex number, and from the final output, what I will do, I am going to take out the real part, so that that will represent the sum of this expression. Okay, so the logic to use the complex number is that we can easily do the calculation using the complex notation. Okay, so we can write xt is equal to, how we can write it, say a naught e to the power, this expression a naught cos omega t, a naught I omega naught into t, you can write it. I will take the real part of xt, so that it will equivalent to this expression, right? That thing I think is clear to you now. Plus a naught e to the power, how I can write omega naught plus phi naught, just you have to write e to the power I omega naught into t plus phi naught, as simple as that, so that its real part is a naught cos omega naught into t plus phi naught. Okay, plus a naught e to the power I omega naught into t plus 2 into phi naught plus dot dot dot. The series will go on, and the last term will be a naught e to the power I omega naught into t plus n minus 1 into phi naught. This will be the last term of this expression. Okay, so you see, in each term there is the presence of this first term a naught e to the power I omega naught into t. So basically what I am going to do in the next step, I am going to take out this term as a common term. Okay, and then let's see what we will found in the result. Okay, so let's continue this calculation. Okay, so what we will find if we take the common a naught e to the power I omega naught into t, if we take the common, so what I will get, first term will be 1 plus the second term will be e to the power I phi naught, because if I take the I common, then omega naught t plus phi naught, the second term will be e to the power I 2 phi naught plus dot dot dot, and the last term will be plus e to the power I n minus 1 into phi naught. Okay, so this is a n term series, and its ratio is the ratio between first term and the consecutive terms are e to the power phi naught. Okay, their sum will be therefore a naught e to the power I omega naught into t. So what will be the sum? A minus a to the power 1 minus a to the power n, that means I phi naught to the power n divided by 1 minus a I phi naught. So this is the sum of the series, and here n, because there are n term, first term, second term, and this is the n term. Okay, so this is the final outcome of the expression. Okay, so here also we can do something, a naught e to the power I omega naught into t. Suppose we are going to take common as e to the power I phi naught n divided by 2. Let's take this as common. Okay, so this will be, you see, e to the power m whole to the power n. What is the value? E to the power mn, right? And just power things just multiply. Okay, so here the final term was e to the power I n phi naught. Okay, and we are taking out how much? E to the power I phi n divided by 2. Okay, so in order to have this term as 1, the other term will be e to the power I phi naught n divided by 2, so that when you multiply this term, you will get e to the power 0, that means 1. Okay, so I hope it is clear now. Minus e to the power I phi naught n divided by 2. Okay, and similarly if we take this term out, a phi naught divided by 2, the first term will be how much? E to the power minus I phi naught divided by 2 minus e to the power I phi naught divided by 2. Okay, so we can take now we can further simplify this to quantity. Okay, because if you remember, sine theta is equal to how much? E to the power I theta minus e to the power minus I theta divided by twice I. This was the expression for sine phi. Okay, so if you take a minus sign out of this bracket, minus will cancel out. So we can actually, our aim is to write this bracketed quantity with respect to sine function. Okay, so how we can write that? A naught e to the power I omega naught into t so e to the power I phi naught n divided by 2 e to the power I phi naught divided by 2. So this thing we can write sine what will be the value? Theta value here. What is the value of theta? Phi naught n divided by 2, right? Here the value of theta is phi naught 2 phi naught into n phi naught divided by 2. Twice I divided by twice I will be there. Say there is a twice I here, but it will automatically get cancelled because another twice pi will be in the denominator. So therefore this term will be phi naught divided by 2 divided by twice I. Okay, so this twice I will get cancelled out. So finally what expression we will get? A naught, okay, sine n phi naught divided by 2 divided by sine phi naught divided by 2. Okay, now these are the complex part. Okay, so we can write it like exponential I omega naught into t. This part was there. Then what the other part was? Exponential I phi naught n divided by 2, and next part was exponential minus I phi naught divided by 2. Okay, this part was there. Okay, so then we can slightly rearrange it. A naught exponential, this term I will put it here, omega naught into 2. Okay, so then I will write sine n phi naught divided by 2 divided by sine phi naught divided by 2. Okay, then I will just add up these two terms. Okay, so this term will give basically exponential I take out I n minus 1, okay, phi naught divided by 2. Okay, so if I write the final expression, it will be like this: a naught exponential I omega naught into t sine n phi naught divided by 2 divided by sine phi naught divided by 2 into exponential I n minus 1 phi naught divided by 2. Okay, now I can add this part 2 also. Okay, so we can write a naught sine n phi naught divided by 2 into sine phi naught over 2 into exponential. If I take I as a common, this part and this part, I am just going to add up these two parts. So it will be omega naught into t plus n minus 1 into phi naught. Okay, so this is the complex resultant z. Let's put it as z, the complex resultant. Earlier I put it as x, but the real it should be really designated by z quantity. Okay, so from z, how can we get x value? Thus we have to take the real part of this expression. So real part of z will be, real part of z is equal to nothing but the resultant oscillation, and its value will be equal to how much? We have to take, this is exponential I omega naught t plus n minus 1 into phi naught. Its real part is nothing but cos omega naught into t plus n minus 1 into phi naught. Okay, and these two are real part only. There is no complex quantity here. So the real part of z, which is nothing but the resultant amplitude, due to the superposition of n successive waves, it will become a naught into sine n phi naught divided by 2 divided by sine phi naught over 2 into how much? Cos omega naught into t plus n minus 1 into phi naught. So this is the final or the resultant amplitude of the simple harmonic motion when n number of simple harmonic oscillator having successive phase difference superimposed. Okay, so in the next part of the video I am going to plot the amplitude of this resultant vibration as a function of wavelength, or as a function of phase difference. So it can be found in the next part of the video.